there's an unfortunate social phenomenon that seems to happen with human beings, which is that the more distance that you travel, the more credibility you seem to have. So they brought me here from Tokyo, and so I'm supposedly very credible. So I'm going to use this as an excuse to talk about, my networking religions. Some of them. One of them, I really have 3 talks here. One of them is about simplicity. One of them is about routing security. And if we have time, I have a little sugar for dessert. And just so you have an idea, I work at a company called An Internet Initiative Japan. It was the first commercial ISP in Japan, so it was kind of an initiative between many people. It's an Asian and some US backbone, commercial customer base, not consumer. Consumer is NTT, the telephone company. It's internet. We are not a telephone company. We don't do MPLS. We don't do ATM, etc. We deliver packets. Okay? So for first commercial IPv6 deployment in the world, and many of our programmer researchers did the IPv6 stack that you're running today. It was a Kame project out of Y. So that's kind of where I come from. We're old-fashioned. We do internet, not ATM, not ATM2, otherwise known as MPLS. We do VoIP over IP. We do IPv6. It's a big seller. It puts the P, privacy, back in VPN. Quality and high touch. Japan is very quality conscious. So, and a very unusual thing these days, we're profitable. Then, let's see if I can pull up another one here. This, and it should work. Okay, so I want to talk about complexity and the difference between the internet and the telephone philosophies. Okay, that's still in here, huh? Okay, the internet really does work, despite the fact that people tell you, oh, 5 nines, the internet really does work. IP forwarding is just as fast as switching. Actual measurements show quality of service is just fine due to proper provisioning, over-provisioning due to the low cost of fiber. And proper provisioning is cheaper than adding a layer. QoS is really a decision of whose packets to drop. I'm not paid to drop packets. I'm paid to deliver packets. So I really don't believe in QoS very much. And there are reasons the internet has taken over the data world and threatens voice. And that's because it's highly successful, disruptive technology, and actually works. Okay? So we shouldn't be trying to say, oh, voice is so much better, we should emulate them. We should say, we've already beaten voice. Take the lessons. Okay? Reliability and resiliency are the core strengths of the internet. Okay? It was designed for reliability and resiliency. The weakness is security. And the telcos used to be, if you remember the old 2600 stuff, etc. IP routing yields as good service as MPLS and better in cases of multiple or extreme failures. We have a saying that the internet routes around damage. Routing protocols really do work. The only real problem is scaling. This is a statement from Mike Odell, who was the original CTO of UUNet, for those who are old enough to remember. Everything else inherits from scaling. If you can scale, everything must be working. In other words, if I can take my processes, my operating, my hardware, etc., and do 10 times as much, then the techniques I am using are reasonable. If I can't, I should be very suspicious. Okay? Complexity is the enemy of scaling. Okay? The telco culture, the telephone companies started to glorify complexity in the 70s. They wanted to compete through complexity. So they added more and more features which complicated their networks. They could throw 10,000 employees at something, and did, to raise the competitive bar against their competitors. But what they ended up with is a network that meant voice is no longer profitable. Right? They complicated 800 numbers, portability, all these features they added. And then they turned around and voice was no longer a profitable business unless you owned the copper monopoly. Okay? So we, the internet people, the OPEX, operating expenditure by the way, we're all in a commodity market. We're all buying from the same vendors. Okay? All our competitors are buying from the same vendors. So don't complicate it. And there's a joke, RFC, that says, with sufficient thrust, pigs can fly. This doesn't mean we can afford the fuel costs to fly pigs. And we don't want to fly pigs. We want to do something efficiently and profitability. Okay? The control plane, the routing plane researchers, there are a significant number of them who have only studied one particularly large ISP. That large ISP has wide-scale control plane disasters more often than they have management reorganizations. That's like twice a year. And if you read NANOG, you see this. Okay? They're a big American telephone company. Okay? And guess what their solution to these failures is? Add more complexity. So you will see proposals now for central routing control systems. Okay? And when you hear centralized on the internet, you know you're in trouble. Because it's a single point of failure, or, oh, we'll make 6 of them so it's redundant. That's the same philosophy as the telephone switches. Big, complex, and have to be armored. Voice had stupid edge devices, telephones that until the mobile phones were very stupid. A desktop phone makes pulses and does noise, right? And a very smart center of the network. The internet has smart edges, computers, okay? And simple stupid core, packet forwarding, and that is it, okay? Adding an entirely new internet service because of the stupid core is just a matter of distributing application to the desktops that want to run it. So if Robert and I want to try a new application on the internet, we just do it. And the internet carries the packet, and all of a sudden Skype is born. All of a sudden HTTP is born. All of a sudden email was born. Email was not part of the original design, by the way. This was a new added application. Okay? This allowed the internet to be a disruptive new technology. And this is because the center of the network just moves packets. When you see somebody talking about putting smarts in the center of the network, realize that it's going to kill that ability. Okay? Think about what it's like adding a new service to the voice network. You have to go modify all these big, very expensive telco switches. It doesn't work. It doesn't happen. They don't have innovation. Okay? When's the last innovation you saw in your desk phone? Okay. The reliability is interesting too. The telcos get reliability by very smart and big central devices. They're heavily protected, rooms full of battery backup, all these things. The internet assumes failure. right? Routing protocols, we run routing protocols because we assume things are going to break. Circuits are going to break, routers are going to break, etc. So we run dynamic routing protocols that route around the problems. For instance, the DNS root servers were seriously attacked multiple times without customers noticing. Right? The internet is about building a reliable network with unreliable components, as opposed to putting all your effort into reliability of very large, complex components. The carriers, the telephone companies, talk about 5 nines, etc. The famous 5ESS switch, which regularly has 5 nines in operation and has even hit 6 nines in the field. We think we want that in routers and other internet boxes because the telephone people tell us they have 5 nines reliability. By the way, when they tell you about that, they don't mention beep, 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 or man, 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 etc. That's how they deal with congestion. Right? That's not counted in the 5 nines. Okay? Can we achieve this? Well, let me tell you, they don't even achieve it. 5ESS switch, and I have friends who worked on it, there's a supervisory function which continually runs around cleaning up inconsistency in the internal data structures that are poorly denormalized. Without, this supervisory function is almost half the code in the switch. Without that running, the 5ESS crashes in a few hours. That's not the way to run things. It's insane. This approach doesn't work to internet routing because we can't have something running around cleaning up the data because internet routing is distributed. It's not centralized. So simplicity wins for us as opposed to large-scale centralized complexity. So I think that instead of having central control, MPLS, ATM, and these things, there's an old saying that spread it across the layers, do things right. It's always possible to take multiple separate problems into single complex interdependent problems. This is a bad idea. This is why ATM failed in the internet. It tried to solve QoS, traffic engineering, circuit building, etc., all at the same time. Every old idea will be proposed again with a different name and a different presentation. We now have the same attempt going on with MPLS. Okay? Now, by the way, I'm not completely against MPLS. There are traffic problems it does solve, if used carefully and in a limited fashion. But I think that layer 2-3 technologies have costs proportional to software costs. They drop very slowly, right? These technologies are all software intensive, they're provisioning complex, they're not automatic, you have to manage it, you have to provision it, you have to maintain it, etc. So it's proportional to software kind of costs, which drop very slowly. Fiber bandwidth pricing seems to follow Moore's law, with costs halving every 1 to 2 years. These are hardware costs. So I think don't increase muxing games, etc., like MPLS, because those costs stay high, and instead decrease, don't get on the fiber bandwagon, use DWDM, use lambdas, etc., and push the stuff down a layer, right? Packet over wavelength, okay? Bet on simple and cheap. Do it stupidly. I'm old, as stupid and lazy as possible, okay? Layer 1 fiber costs are falling at rates driven by hardware. Layer 2 is driven by software, which is not falling but is rising. So therefore, provision the bandwidth you need. Okay? The truth is, I do not really know fiber costs here in Poland, but I know them in Asia, I know them in the States, I know them in Western Europe, and so what's going to happen when fiber costs keep falling, as they have been, and the big providers and everybody, they provide cheap transport, and the last kilometer monopoly is broken by wireless and WiMAX, and I'm helping deploy WiMAX in Africa, okay? Peer-to-peer becomes even more dominant, and VoIP replaces the telephone network. There's only so long that the government and lawyers can save the telephone companies, right? They are the dinosaurs that unless they can figure out how to move to the modern age, they're dead. They're like the record industry. They have a serious problem that they're not going to be able to protect with regulation, lawyers, and governments. In the long term, they're going to have to innovate. And how do they innovate? They have to climb up the stack. They have to get in front of the technology. They have to use VoIP. And for instance, in Japan, where I am, Japan invested in fiber early and big. I, in my apartment, pay the equivalent of $30 US a month for 100 megabits, full duplex. I can get 80 megabits with TCP tuning from my apartment to the United States for $30 a month. They heavily invested in fiber. What happens is if you order a telephone, you actually get a VoIP phone, VoIP phone, but you don't know it. And it's actually an IPv6 VoIP phone, but it's not connected to the internet. It's a walled garden, IPv6. So it has gateways to the internet, so it can connect to the rest of the world, etc. But NTT has already moved. They need to provide innovative services. They need to cooperate with the peer-to-peer networking instead of fighting it. Okay? The customers want peer-to-peer. Fighting with your customers is not a path to success. Okay? So not just video on demand, but mediated peer-to-peer. You see the P4P stuff, etc., where the providers and the peer-to-peer software developers are trying to cooperate and say, the reason I as an operator had problems with peer-to-peer is because it was not using my network efficiently. So if I give you information about my network topology, maybe your software will use it efficiently. And there's a trade-off there that people are playing with and exploring that technical space. So, I think that, this is a joke I'm half operator, half researcher. So I think that with enough complexity, we could operate an approximate internet in polynomial time and dollars. For those of you who didn't do math, this means that the time and dollars go like that. You don't want it. And we're working on a proof that we can make it NP hard. And then we're just going to wonder where the profit went, like the telephone companies. Right? Don't make it complicated, because you're going to give your money to the vendors. I worked at a very large American telephone company. The internet people saw a path to power, that they could displace the frame relay people and the ATM people and the circuit people by doing everything over MPLS. And then they would control everything. This company was 130 years old, and politics were more important than profit. So they replaced frame relay, ATM, etc., with MPLS. And what happened was, those old frame relay and ATM businesses were antiques, but they were profitable. Where did the money go? It went to router vendors. Oh, look at me. Right? So they took profit and turned it into capital expense and complexity in managing their network. And that network has control plane problems that are major. Take half the network out every year, once a year. I want to thank for this PLNOG, of course. I work at IIJ. I have a grant from Cisco, the Internet Society, and a large American telco who did not listen. And it's been very expensive. And in fact, that large American telco, I left, and 6 months later, they were sold. Cheap. Right? You don't want to be there. People should feel free to ask questions and interrupt me, by the way. And I'm now, otherwise, if you don't have questions, going to move on to routing security, which is another religion of mine. Okay.
No questions?
So I've been working on a resource public key infrastructure based on X509 certification of resources. By resources, I mean IP addresses and AS numbers. And what it uses is RFC 3779 extensions to X509. RFC 3779 describes an extension which allows a certificate to describe IP resources, mainly IP address space and AS numbers. So you could have a certificate saying with some signed by some public key, private key that contains the public key of somebody who controls 147.28.00/16. And the way this would work is that, for example, there's stuff in the tree above this, but say IANA gave somebody a certificate for 192.168/16, and it gave it to some ISP. And the ISP, IANA would sign this with their private key, and this would be able to be validated formally, cryptographically, that this allocation was given to this entity. This entity could then take a /20 and give it to this person, take another /20 and give it to this person, a different /20 of course, and take a /19, give it to this person, and so on down the tree. Okay? So a public key hierarchy certifying the right to use address space. Okay? That IANA could give to the RIRs could give to the individual ISPs, the ISPs could give to their customers, and so forth. Okay? There's one additional hack, which is a route origin attestation object, which is signed with the private key of whoever owns the address space, and it says, for this address space, this is the AS that may announce it. And there could be many. I could have 5 different ASs that could possibly announce it. You'll control with BGP routing who actually announces it. But this says, I authorize Robert to announce this prefix as an AS. So you have a formally, in the cryptographic sense, attestation that that AS may originate this prefix. So you could have a global database of these certificates and these right to route, okay? And actually, we've done this, by the way. I'm describing software that exists today. This is a project of the last 3 years, okay? The RIRs, Wright was very late. AP, Nick, and Aaron drove this. So this database is in fact distributed. So IANA has a portion of it for the stuff they're responsible for. The different registries have portions of it for which they're responsible. And it is envisioned that, like the Internet Routing Registry, there'll be 50 or 100 different sites that run their own. The big ISPs, UNet, Level 3, et cetera, will have their part of the registry. Okay? This is the software we've written. It's public source software. But essentially, this is the ISP or the RIR or IANA, their back end, and they're, the resources you have in control. This is the RPKI engine that publishes this stuff, and you can add a hardware signing module too if you're into heavy security issues. Okay, and this software exists. So the idea is an RIR, for example, has an ISP as a customer. And when the ISP becomes a customer, they exchange the keys, and then the RIR puts in the public key infrastructure records for what they've allocated to that ISP. Okay? Hey, that ISP has this address space, some address certs, and has these ASNs. That ISP, similarly, when it has a customer, a downstream ISP, does a very similar thing, a contractual key exchange, and then puts in the certs for the sub-allocations. And then this ISP can put in, for instance, end customer sites, etc. And of course, everybody puts in the right to route when they're an end. This database, it is, in the long term, will be replicated, and there are protocols for replication distribution. We're already done. Across the ISP's routing infrastructures. Okay, but we're talking about 3 to 5 years there. There are implementations that currently exist. APNIC has a prototype. Ripe and Aaron and others are deciding how to deploy. This is just technical garbage. But the registries are deploying, a number of them. Ripe, APNIC, and Aaron claim they're going to have the prototype deployments out by the end of the year.
So Randy, I have a question. Can you come back to the previous slide?
I think so. Let me see. Yes.
No, previous. One more. Okay. So there's a founded project from the government of Japan regarding this kind of validation. And we are working with NTT to actually designing the router part interface to the rest of the system. Do you know what protocol will be running between the replicas and the actual routers to get the AS source plus the prefix tuples?
Yes, we've designed such a thing, but we're trying to actually work with the vendors on that. We have not talked to Jimmy.
That's a problem.
We have talked to another vendor.
Currently, NTT is using Quiz. We're thinking about LDAP, maybe something else.
No, that stuff's crazy.
So that's something.
That stuff's crazy. We should have a little talk.
Okay.
That's not. It's interesting though. I live in Japan. I have been working NTT's network. I originally built, and I now work for IJ. I've been working for Japanese ISPs for 10 years. And my children are grown, and my wife and I said, we really like Japan, let's move there for a year or two. So that's why we're there. I talked with the Japanese JPNIC, Asia Pacific, APNIC. How many, are people all here familiar with the registries? How many people here know what RIPE is, et cetera, et cetera? Right, Joe? Right. Just checking. Everybody's so quiet. This is like talking to a Japanese audience. Let's have a little noise. So APNIC, unlike the other regions, has some national NICs. There's a Japanese NIC, a Chinese NIC, a Taiwanese NIC, a Korean NIC, and I know I'm leaving somebody out. HK is? I don't know. Who cares? The Japanese NIC wants to sign who is routing data, wants to sign the Internet Routing Registry object. And we're having a fun discussion because of the culture of Japan. They view identity as very different than the States does, and I believe most of Europe does. Their personal identity is very strong. I have a little stamp. It's called a hanko, and that's my signature. If it's stamped on something, that's it, right? And so when I say to them, so what they're thinking of is issuing certs to individuals, you know, that you will stamp your little hanko stamp, and you will get a certificate, and you will use that to sign your data. And I explained to them, this works in the Japanese culture, and I respect that, but in the West, everybody's going to say, that's entirely forgeable. That's not trustable. I want something authoritative. Okay? So this scheme is meant to be authoritative in a more formal Western sense. Okay? And some of those NTT guys are working with JPNIC on that one. Why do I care about this stuff? Well, first of all, when somebody comes to me as an ISP and says, I have this 24, please route it, how do I know you have it? Right? How many people here read the PLNOG mailing list? Oh, very few. They're smart. But there's much discussion there about people having hijacked the WHOIS data at the registries and taken other people's IP address space. Specifically, spammers have gotten 2/16s, etc. So when somebody comes to me and says, route this address space, please, WHOIS so-so. We all know the WHOIS data is not great. Although RIPES is somewhat better than the States, but not much, let me tell you. So when they come to me and want me to route their address space, I want to be able to go someplace formal, where I can validate. I want them to sign that object and say, here it is, clearly I own it because you can validate it all the way up to the IM. Okay? I want to automate the building of route filters, formally. And then in the long term, I want real routing security in the routers. And one other thing is, I believe that as IPv4 runs out, we are going to see formal trading, that's buying and selling, of address space. So when you say to me, you're going to sell me that piece of address space, I want to know that you really own it. I'm about to pay real money. Okay. So, Rüdiger Volk of Deutsche Telekom has come up with a really cute hack. How many people use IRR-based filters? Very few, okay. This means taking the data from the routing registries and building route filters so that when I get a routing announcement from a peer, I know that they should really be telling me about that. In other words, they or their customers have registered that address space. So Rüdiger is going to take ROAs to generate a fake registry and put it in front of the other IRR data. This means no software changes, no database changes, and all my existing stuff just works a little better, a little more formally. This is not full formal validation, but it's cheap and easy. Okay? But where I really want to go in the long run is BGP routing security. A vendor with whom I'm working is actually doing, and starting to do, origin validation. In other words, remember that ROA that says AS42 may announce this address space that I own, formally verifiable with certificates. So, we're trying to do the compute traffic load stuff. They're not going to do path validation until they do origin. And we need to get other vendors on board, Robert.
No, we are doing that, and I have a question on that slide as well. Because
this is the slide you were talking about, actually.
Yeah. There are two main ways you can do this validation, either with the whitelist or the blacklist approach. And I think it would be nice to sense even people in the room which approach they would prefer.
What's a blacklist?
Blacklist, you only insert destinations which are hidden, which you detect it first and you withdrawing from the BGP. Whitelist, you validate against the good entries and throwing away everything else.
Could you go against to repeat the description of the blacklist?
Yeah, blacklist.
How can I formally define what you should not have?
Because it's not in the IRR database. You receive a prefix from
the IRR data is garbage.
Well, whatever you validate against database. You know your entries, which should be kind of valid. Then you receive the prefix.
I want it formally.
Okay, formally valid. You're receiving the prefix from your customer as the ISP, and you compare it against the list. It's not on the list, so you know it's an edit. You have to withdraw it from BGP, so it's a blacklist. Your router does the blacklist validation, or you can do whitelist validation. Both has pros and cons, and it's a decision to be made which mode to operate.
If the blacklist is dynamically determined as what is not in the whitelist, then you're talking about whitelist validation.
No, the property of the blacklist is that there is delay in doing the validation in produce. So you advertise bad route and then withdrawing it later. That's the price you pay for reducing number of entries in the router to actually check against your...
Oh, you're talking about how you deal with delayed validation.
Yes, exactly.
It's not really a blacklist, it's how you defer validation.
Well, no, it is, because with whitelist, you put into the router, let's say, 100,000 entries. With blacklist, maybe 10 entries. That's a big difference between those two approaches.
I think...
We can take it offline.
Let's go into this in a few minutes.
Okay.
I think... So, there's a big question of how you get this stuff to routers. And so, on the network, there's this distributed database of the RPKI. There's a protocol that gathers it in a replica. And I believe I think there are two models. One is that I'm going to have a system in the POP that has the replica that all the routers, since they're in the same POP, can have a trusted API to get to. Okay? There are others who just, the router's big enough, the router's going to do it all. Okay? But we're defining this protocol so that the RPKI can be gathered from the network, replicated in each POP, and then the routers in the POP get the valid stuff. Cheap. This would also happen, for instance, in an enterprise edge. Okay? It has to work with origin-only attestations. It has to work with all certificates, should not be vendor biased, and it must work when it's all stuffed inside a big router. We need to get Juniper into this too.
Of course. And the router doesn't need to be that big. That's the point. It's just control plane memory. Cheap.
Right. It's cheap from Juniper, but it's Cisco. That $125 piece of RAM costs $8,000. Yeah. Okay. So, validation will work well for configuration errors, e.g. the YouTube incident, right? It will not prevent even all misconfiguration issues, but it will prevent most of them. But it will not protect against real routing attacks. How many are familiar with what Tony and Alex did in DEF CON? Okay, that was a formal routing attack where they demonstrated that they could take over and insert and grab data between source and destination for an arbitrary source and destination where you couldn't even see that it had been done. Trace route. Got fooled. Okay? A real routing attack. The kind of thing that the black hats will use to go after money. This is an example. This is a kind of theoretical example of it. I'm going to operate at a high level. There's a transaction going on this way between A and B, and the dollars are going along. Okay? Z diverts the traffic to themselves, takes out the dollars, and sends the traffic on. How does Z do it? Okay? We have in most of the routing protocols the idea of cost, metrics, whatever you want to call it. And that's why this is kind of an idealized situation. This is not exactly BGP. Okay? So there are these costs, and notice it costs 15 to get from here to here, and to go this way costs 30. So the traffic flows that way. Okay? So what's really happening is Y is telling X that it can get to B for a cost of 5. X therefore tells A that, and Z, that its costs to Y are 5 and to B are 10. So Z tells X that costs are more expensive, so therefore the traffic flows this way. What happens when Z tells X that it can get to Y in 10, and oh, by the way, I can get you to B at a special discount today. Only 4. And guess where X sends the traffic? Okay. So, why is this a hard problem? X does not really know what links Y or Z has. And they trust each other for costs. Now we'll notice that Z also did not lie about the origin of the prefix. So origin validation didn't help. Validating the prefix ownership did not help. Using IRR-like peering maps doesn't help. Z wasn't lying about their topology. Okay? What does help? Okay. This is called forward path signing, and it's like a protocol that's been described for 8 or 10 years called SBGP, which is when B announces the prefix to Y, B signs it cryptographically using those certificates I'm talking about. And B says, I am giving Y my prefix, and the cost to Y is 5. So that when Y sends its message to X and Z, Y signs them with its signature saying, by the way, I can get to, I'm sending it to X, okay? And X can get to me at a cost of 10, and it encapsulates this signature and this object with B's signature. It cannot forge this, right? Because that was signed by B. So Z can only sign this object. So Z cannot tell X that it can get the discount. Okay? So X can verify the paths and the costs. We'll call this forward path signing because when I hand the prefix there, I'm saying I am handing it to Y. I'm telling you my forward announcement and signing it. So it solves the simple case of these router hijacks. Okay. The costs are that it's CPU intensive. Those costs are falling very quickly. CPU chip is, a crypto chip's now quite cheap. You can use caching, you can use pre or delayed validation, which is I think what Robert and I were getting into. As I said, Moore's Law is our friends, the chips are getting cheap. And most announcements are boring. We actually looked at a peering router and we found that 60+% of the announcements we heard the same announcement within a short time period. So if we cached the validation, we would win. Okay? Path validation is near a protocol called SBGP, Secure BGP. It came out of VPN. It's the right direction because it's congruent with BGP. You notice when I described the forward path signing, there was no new external topology databases. There was no new anything. It's congruent with BGP. It's BGP augmented. That's all. Okay? So it does all we know how to do, but it needs work. The protocol was designed by some theoreticians who've never deployed anything. So it needs some work, and we're doing that. Okay? So what we really need to do is finish the RPKI deployments. There's some drafts in the ITF that need to be completed. This was work, the RPKI, the routing security stuff, was done outside of the ITF. And the ITF has a motto of running code and rough consensus. We have t-shirts that say running code and run away before somebody comes to help. So we actually have running code and somebody else is trying to take it through the ITF, a many-year effort. We're deploying a test bed. We need origin-only validation for the routers out of routing vendors. Then to move on to SBGP and an SBGP test bed. Okay, and we're actually working on that series of things. And thanks to the normal people. Want to have a little discussion of this one now, or?
Do you have any questions in English or Polish I can translate, please? Anything Randy said you don't agree with, or you agree with? Yes?
Come on! More coffee, do we need? It's not here. Everybody's asleep?
We are curious of your discussion.
Of our discussion?
Yes.
Let's continue.
Okay.
Okay.
So what I'm saying is, okay. First, there are many people working on things in the routing area. There are people. This formal BGP security will be 3 to 5 years before it's out. Okay, and it will take a lot of work. And they're saying, in the meantime, we need to do X, we need to do Y. There's Jennifer Exford and, how embarrassing, out of New Mexico, have a protocol, or they're trying to say, hey, you know, when I hear a new announcement that's new, it has it's less valid than old announcements for the same thing. And I wait a while to believe it. And things like that. I think many of these approaches are interesting, and I encourage them. I'm getting a little old, and I only have so much time, and so I am very focused and concentrating on formal long-term solid solutions. There are many good shorter-term interim paths. So I don't want to say they're bad. I just don't have the time and energy to work on them. Okay? And one of them is the work going on with JPNIC to use what's called identity certs to sign the IRR WHOIS data. I don't think signing WHOIS data is going to make it any better. We have an idiom in American to try to make a silk purse out of a pig's ear, which just doesn't happen. Robert, you wanted to...
No. I think we have a lot of things in details to clarify between us offline, and perhaps at the next session we can present some product doing the validation.
I would love to.
Okay.
Love
Thank you, Randy, for your talk.
Well, we have time for dessert.
You have dessert as well.
Okay.
Perfect.
And I believe I have 10 minutes left.
Yeah, sure.
Okay. So this will be research that is not yet, it's in publication. So this is not formal, and this is not a good presentation yet. And really, there's some interesting stuff in the big surprise I'm saving for the end. Okay, problems. We cannot see routing data at the edge. How many people are familiar with route views, RIS, et cetera, et cetera? These central points where routing data is recorded. Ooh, small number. Okay. These are central facilities where many of the ISPs give their routing data to them, so you can go look and see what this routing information is. Many researchers use these data. But it doesn't come from the edge of the internet, from the enterprises, from the small ISPs, from home users, etc. So the control plane data we have is very weak at the edge. In papers we wrote a number of years back, we showed that the control plane, looking at these data, were poor predictors of the data plane. In other words, we did a study. People said, oh, code red and the NIMDA, look at all these routing fluctuations. Much routing exchanges going on. This must mean packets got lost everywhere. And when we actually went and looked at packet loss, wasn't there. Okay? And what it really was, as I described in the first talk, is that routing data, the control plane, was like white blood cells, I like to say. It was fighting the infection. So when you are sick, your white blood cell count goes up. Many routing announcements. And they're fighting the disease. And they're fighting it successfully. The packets were actually happy. They got them. Okay? So, we've been doing a lot of studying comparing the control plane and the data plane. In other words, packet routing information to packet transport information. Okay? And we find the relationship is not simple. This study started out specifically as a problem for bogon route filters. In other words, many ISPs filter announcements, do not listen to announcements of space they know is not allocated, 68/8, et cetera, et cetera. And then when it becomes allocated from the IANA to the RIR to the ISPs, there's a whole bunch of that stuff that doesn't get updated and is stale. So you get a new address space from a routing registry, and it's very hard to use because the filters aren't there, or haven't been removed. So Aaron funded a study to look for that stuff. And what we did was, out in probes, there was a paper a couple years ago, let's forget. It's out probes. We probe to the edge of the internet, we have IP addresses we go to in most ASs of the internet, about 88%. And we can ping out there and see if they hear us. Now, we have an unfortunate problem, and all previous studies have the problem that they sent the packet out, and when they did not hear back, did they not hear back because that destination was down, or because there was a filter? So what we did was we have a technique that we call our dual probe technique, and this was a new technique for the study, where we ping from an old known address space. And if we get a response, then we know that's alive, and then we can send from the test prefix. Okay? And so that's another picture of the same thing. What we did was Aaron gave us some test prefixes in 173 and 174 that had just been allocated by the IANA to Aaron. And we announced them from different ASs scattered around the world. And this is the anchor IP, the old one that we know is good. And when we got a response, then we used the test prefix. Okay? And we tried ICMP probes and UDP probes. And we found that UDP probes got very high proportion of no replies from everything. So we went with ICMP. Okay? And this just gives you an idea of how many ASs we covered. We tried to get at least 5 IPs in every AS. Then there are some you can't because, Shell Oil Company has a /22, and there's really one address in it, and it's heavily filtered behind, firewall. So, there are stub ASs, in other words, ASs that don't seem to offer anybody transit, and they're transit ASs. Okay? This shows you the big problem looks like it's stub ASs. These we know to filter, these probably filter. Okay? And over time, we measured 3 months apart, and they don't go down. But I wanted to tell you the fun one. The purpose of this is to get you to understand a little what we were doing. And when we were finished, I'm working with Olaf Menel from Technical University Berlin on this. Olaf says to me, hey, why don't we announce a /25 and see how far that gets? Now, that's not supposed to really get anywhere on the internet, right? The story we have is everybody filters /24s. Well, so we announced it. And Vario, for instance, said, we'll listen to that. I told us we will listen to that announcement, but we will give it to our customers, but not our peers. And so we made the announcement of the /25, and we went and looked at the big routing databases. And those big routing databases said 15 different ASs actually reported hearing that /25. This is kind of what we expected. But then we used the data probes to probe from that /25 out into all the ASs we could get on the internet. The number that responded, in other words, the number of ASs that actually had good routing to that /25 were 1,025. This means if you do research based on the RIPE database or the RouteViews database, if you're doing routing research, you're standing on very bad ground. Okay? And to give you an idea, the average path length, in other words, how many ASs a route goes through on the internet, is about 4. Okay? The /20 that we announced, you know, here's how many ASs had 2 hops, had 3 hops, et cetera, et cetera, et cetera. The /25, when we announced it, we saw something very similar with the long tail.